with an Altera FPGA for fan out, timing system, power system, and using a fiber optic cable will go to this, which is a pizza box where they can read out, inject timing signals and synchronize the whole system. So this is like a little mock-up with 2 panels for the Australia system. So 1 square meter. This is the same type of system, but it's a single panel, 24 centimeter. And here you can see. I'll show you this guy here first. So these are actually pads. So these pads are actually the anodes. This is what collects the charge. So what happens is, so this is actually sitting in here, facing in this direction, like around there. You have a cathode, a window here where we apply up to 1.5 kV. We have 4 centimeters of drift of a volume of helium-3. Thermal neutron comes in, interacts within that 4 centimeters of helium-3, generates a charge. Because of the cathode and the anode sitting at ground, the charge drifts and eventually gets collected by these pads. Mm-hmm. These pads go to an ASIC, preamp, shaped, converted over the ADC, right, and then sent out to an FPGA, which then sends it out over this cable. So FPGA goes over this cable to this power supply board, which is in the back. So you can actually see, so this is actually all the electronics in here right now, so it's kind of sitting like that. Mm-hmm. And
also like in this back case. Right?
So this one's in this basket, so there's a flange here. So this is actually representing a flange, this little connector here. And actually, as we speak, I'll reset this here. And these are thermal neutrons coming in right now from Cosmics. I mean, these are cosmic neutrons.
So essentially,
that's crazy.
The cool. Neutron interacts with the helium, and then I guess the ions they produce, or
right. So it interacts with the helium-3, mm-hmm, producing ions, and because we have a field in here,
and that's
the field pushes the ions, mm-hmm, onto the pads, and the charge gets collected, right, on the pads, and then we read that out.
So it's like there's a middleman. So it's not the actual thing that you're seeing, but the effect of it.
Correct.
Okay.
I mean, for fast neutrons, they look at recoil, meaning so you can never look at the neutron itself. So for the fast neutrons, it interacts with whatever material they use. Mm-hmm. It generates kind of like a Newton cradle where it bounces. One thing hits another, and it generates a track of different charge, and that's what you collect. So in most cases, in most of these detectors, that's actually what we're looking at. We're looking at the